All right, so we're going to start chapter 3. It is like we start exponential, and then we do graphs of exponential, and then we do logs, and then we do graphs of logs, and then we do properties of logs and equations of logs. There's actually only 4 sections. We're going to do the first 3. You'll take a quiz, which is next week, and then we'll do the last one, and you'll take a quiz the following week. A test the following week. Those will be the first 2 major grades of quarter 2. All right, so the definition of an exponential function is this. An exponential function has a base and an exponent. So the base in this case is a, the thing that is being raised to the power is called the base, and then obviously the power is called the exponent. So base, exponent. The base will always be bigger than 1, and it won't equal 1. Bigger than 0 and it won't equal 1. 1 to any power is just going to be 1, so it's not changing. That would be constant. These have exponential growth or decay. That number can be a fraction, it can be a decimal, it can be a whole number, okay? But it won't be negative, and it won't be 1. The very first thing we're going to do is just plug some stuff into our calculators. So this says to evaluate the function at the indicated value of x and round your answer to 3 decimal places. So some of this stuff will be calculator based, and then some will not. This one obviously is. Some calculators have a little button that's like y to the x. It'll say something like this. And then some use the button that is called a caret, which looks like this. If you have the TIs, it has the caret. So if I want to find 0.5 to the 1.2, I type in 0.5 or 0.5. And then you do the caret, which is like over the division sign, and then 1.2. You should get 0.4352, which is going to round to 0.435. So 3 decimal places is what I told you to keep this time. For B, it says 150 times 2 to the x, and then x is negative 2.5. So I'm going to first do 2 to the negative 2.5, and then you can put that in parentheses and multiply it times 150, or you could do what the 2 to the negative 2.5, take that answer and multiply it times 150. It's up to you. Just be careful and don't multiply out the 150 and the 2 and then raise that to the negative 2.5. So 2 to the negative 2.5 is 0.1767 and so on. I'm not going to round that. I'm going to use that answer by just hitting enter, and it will bring up the answer times 150, and you get 26.5165, and that's going to round to 26.517. Question so far? All right, now we're going to start to graph. So exponential graphs. If you think about something that's growing exponentially, right? If it's a whole number, the higher the power, the bigger the jump in number, right? If I start with 2, 2 squared is 2. 2 to the first is 2. 2 squared is 4. 4 squared is 16. There's a big jump in the numbers, right? So it causes this kind of a curve, okay? That is an exponential curve with a base that's a whole number. It will start right along a horizontal asymptote, which is occurring at 0, and it will increase so quickly it causes that curve. If the base is a fraction or a decimal under 1, then what happens when you raise a fraction to a power? If you think about a half raised to a power, right? If I did a half to the first power, it's obviously a half. If I do a half to the second power, it's a fourth. If I do a half to the third power, it's an eighth. What's happening with those fractions? They're getting smaller. So that's why it takes on the red shape, okay? It's going to start off wherever it starts, and then it's going to come, which would be positive infinity in this case, and then it's going to come down. It's going to approach that horizontal asymptote at 0, but it's not going to touch it. So there are a couple characteristics about exponential graphs that you got to pay attention to, because we're going to learn how to shift these around and plot some points. But one is that the domain is all real numbers. You can plug anything into the exponent there, negative infinity to positive infinity. The range on your standard parent function, so this is without a vertical shift, is 0 to positive infinity because, again, there'd be a horizontal asymptote through 0, and then the arrow would point up. This is going to start to move up and down, and that will change, but on my parent function, it's at 0. The y-intercept is at 1 for my parent function because no matter what my base is, if I raise it to the power of 0, or you raise any base to a power of 0, my answer is 1. And we just said that if the base is a whole number bigger than 1, it is increasing as it moves to the right. And if it's smaller, if it's a fraction, then it is decreasing and it moves to the right. That's kind of like 3 and 4. 5 says these are 1 to 1. It has an inverse function. It would pass my horizontal line test. And 6 says it approaches but does not touch the x-axis because there is a horizontal asymptote at y equals 0. Now this will shift with a vertical shift. If I take and add or subtract something after my exponent, so not in the exponent, but after the exponent, it causes my graph to move up or down, and that's going to cause my asymptote to move up or down. That's going to cause my range to move up or down, okay? So those kind of things are still going to happen to these graphs. We're going to start with plugging in points. Like you've never plotted exponential function before. So we want to do a mix of negatives and positives. I'm just going to do 3. We're going to pick -1, 0, and 1, and we're going to see what happens to this graph. So if I take and I plug in -1, I get 3 to the -1. What's 3 to the -1? What happens when you have a negative exponent? It becomes 1/3. That 3 goes to the bottom. Okay, so this becomes 1/3. 3 to the 0 is 1. And 3 to the first is 3. And then I'm going to plot those. So this is my coordinate point, -1 and 1/3. This is my coordinate point, 0, 1. This is my coordinate point, 1, 3. Just from plotting those points, I can see my curve happening, but the prior knowledge of exponential functions is what tells me it's got to flatten it out around that x-axis. So there is a horizontal asymptote at y equals 0. My domain for all of these is all real numbers, negative infinity to positive infinity. My range, it's not going to hit 0 and it's not going to go below it, so my range is 0 to positive infinity. My y-intercept, I can either look at my graph or I can go to the center point on my t-chart because that's where I plugged in 0. And it's 0, 1. Questions so far? Okay, we're going to repeat it for B. So same 3 points. 3 to the -1 becomes 3 to the first, or 3. 3 to the -0 is still 3 to the 0, which is 1. And 3 to the -1 is 1/3. So -1, 3, 0, 1, 1, 1/3. So it flipped, and if you think about it, when we have a negative inside the function, which is what's happening if it's in the exponent, it flips our graphs over the y-axis. So it literally flips it left to right, which is exactly what happened here. My graph is going to come close to the x-axis without touching it. There's a horizontal asymptote still at y equals 0, domain negative infinity to positive infinity, range 0 to positive infinity, y-intercept 0, 1. All of that stays exactly the same. The only thing that changed was the direction of my curve. And again, if you think about it, a negative on the exponent here means 1/3 to the x. So I could have just moved the 1/3 and then also plugged it in. Or you can keep it in the exponent. Good so far. All right. Graph these two. Actually, you know what? Graph those two. Set up a t-chart and graph those two.
So this 1/4 equals a 4.
All right, so if I raise 1, if I start with 1/4 to the x, and I raise it to the -1, you get what? 4, 0, 1, 1, 1/4. So -1, 4, 0, 1, and 1/4. Asymptote would be at y equals 0. And then 4 to the x, 4 to the -1 would be 1/4, 4 to the 0, 1, and 4 to the first, 4, good. -1, 1/4, 0, 1, and 1/4. Good? Okay, so we will eventually, and we'll finish this tomorrow. We'll stop there for today. But what will happen is you will start to need to pay attention to things like vertical shifts. So this next slide goes through like all the different shifts, and we'll talk about it some more tomorrow. But the most important one for a horizontal asymptote is a vertical translation. Because if you move, for a exponential function is the vertical translation. Because as I move my function up or down, it's going to change your horizontal asymptote. So every time, and notice the difference, if I add or subtract something outside the exponent, now it causes a shift up or down. If you plug in your points will still map where they're supposed to be, but you have to know to shift your asymptote, okay? And most of the time, it's easier to shift the asymptote and then plug in your points so that you can kind of see that shift happen. So I did post the assignment. It's open if you want to get started. If you know today's going to be a little bit easier than tomorrow, you can start to graph them. Anything about interest, skip it. Like anything about something we haven't talked about yet today, just skip it for now. But you can do, I think there's questions that literally just say like find the value using a calculator like we did start. And then there are ones where you're going to have to graph. All the graphing ones you're going to have to do by hand anyway. So if you want to start plugging in your points, you certainly can, okay? But we will talk about it more tomorrow.